In today's session, Jay Lee will take us through Azure Virtual Network Manager, simplify and centrally manage Azure networks at scale. Jay is a senior program manager with the Azure Network Security team. And without further ado, I'll turn it over to him. Jay, the floor is yours.
Thanks, Jason. Thanks for the intro. You all hear me?
Yes.
Okay, great. Okay, let me share my content. Okay. Okay, can everyone see my screen right now?
Yes.
Okay, great. Okay, thanks for having me. My name is JD. I'm a senior program manager at Azure Networking. So today I'm going to introduce you how you can use Azure Virtual Network Manager to manage your virtual networks at scale. Azure Virtual Network Manager is announced in Ignite as public preview currently, and let's get it started. Okay, so I want to first talk about what kind of the problems Azure Virtual Network Manager tries to solve. So as you can see from this diagram, as the number of network resources grows exponentially, either in your cloud space or in your data center, the management workload and the overhead to manage them efficiently is very difficult. So any error will be very costly, and re-architecting to adapt to your new infrastructure can be very difficult. Oftentimes, customers use a complex pipeline or some template to automate this process. However, this is not that straightforward to many customers, and managing them, crafting them also would be an effort. So this is where we want to help customers solve, meaning we want to help you to manage massive number of network resources, configurations. For example, managing thousands of VNets, NSGs, UDRs, etc. So this is the problem space that we're solving. As I mentioned, network group is a logical grouping of network resources. You can slice and dice into different, segments: dev, prod, test, or by teams, organization, departments, etc. And you can create this by two ways: static grouping or dynamic grouping. Static grouping means you can specify the groups based on the selection of VNets explicitly. For example, you can say virtual networks A, B, C should be in network group 1. Okay, and another way is dynamic grouping. This is the powerful grouping of network, network resources in a conditional way. For example, you can say, I want to have all of the VNets with the tag prod to be in the same, network group called production network group, right? And you can say, okay, I want to apply a mesh, a connective configuration to this network group. Okay, once you have that configuration applied and committed to network manager, those VNets, in the network group, production network group, will be connected. And even if you have a new VNet, after you committed this configuration, network manager would automatically identify the appearance of such a new VNet with that prod tag, and automatically create the connectivity for the new VNet as well. So you can rest assured. So it's very convenient feature. So there are two ways that you can define your dynamic grouping: basic editor and advanced editor. Basic editor, we already created some categories that you can use out of box: ID tags, resource groups, subscription, etc. with GUI. So you can easily create a combination of those conditions with basic editor. But you can also create more flexible, complex criteria using the advanced editor, in which you can define the criteria with JSON syntax. Okay, so this is the network segmentation. Next, connectivity configuration. So connectivity configuration is, as I mentioned, one of the types that you can use in the public preview phase. And so here you can see three kinds of the topologies from the left-hand side to right: hub and spoke, mesh, and hub and spoke with direct connectivity between spoke VNets. So traditionally creating, these topologies can be cumbersome and very hard to scale, especially, let's say, you consider mesh topology. The number of the connections you need to create using peering could be very massive. So this is where you can make it simple by having network manager. Simply, you come to network manager and specify, just like I mentioned, specify the network group that you want to have mesh, and you can click what kind of the configuration you want to have for those network groups. Then you can create the connectivity for them. So we simplify the process. On top of that, using the network manager's capability, you can have higher scale in mesh. So for example, in mesh, traditionally in Azure, the limit of peering is 500, meaning one VNet can connect to up to 500 VNets. But with Network Manager in mesh, you can additionally add to a higher limit. And we specified how many you can add more in our documentation you can refer to. And this is powered by our new construct called connected group. So when you go to the mesh topologies effective routes, what you can see is a connected group to mention this topology. Okay, and I want to also mention, the topology on the right-hand side. So this is the hub and spoke with direct connectivity between the spoke VNets, and it's especially useful when you don't need to have all of the spoke traffic to go to the hub. So let's say you can have some common services placed in the hub VNet, right? And so for the occasions where spokes, don't need to talk to the hub, they can just directly connect to another spoke so that you don't need to have additional hub. So the latency is better. And this is more powerful version of hub and spoke when you don't need to have the hub to be connected to the spoke all the time. Okay, and you can easily create such a topology using network manager, which was traditionally very cumbersome to build without network manager. Okay, so this is connectivity configuration piece. As I mentioned, after creating configuration, what you need to do is to deploy your configuration to different regions. Why you have this design in Network Manager is that it simplifies the way that you test your configuration and roll forward into different regions. So you can easily use Network Manager to create a configuration and test in one region and roll forward to more of the production-oriented regions easily with the deployment feature in Network Manager. I'll show you later in the demo. Okay. So the rest of the presentation, I want to dive deep into the security piece more. So I want to further explain security admin configuration and security admin rules. So as I mentioned, we introduced a new type of the security rule called security admin rule or admin rule. So this is not NSG, and this can live in parallel with NSG. Okay, and admin rule would not impact or change NSGs. They completely live in parallel. And the target audience of this rule would be network admins or central governance team. What you can do is that you can use admin rule to put on the VNet, and always admin rules will be evaluated prior to NSGs. So using admin rules, network admins can always put the high priority rules in front of NSGs so that you can effectively enforce some important network security rules. So in this way, you can effectively protect your environment without touching NSGs. So on the right-hand side, you have the illustration of how you can use this one. So admins, they can say, okay, I want to block, all of the high-risk port by saying, deny high-risk port admin rule. Okay, so in this way, all of the VNets, specified with this rule will be protected by admin rules. So no matter what NSG rules owner, no matter how they modify NSGs, still this rule will be enforced. And another kind of the application is that we also introduce kind of rule called always allow. So you can also say, I want to always allow Windows Update, port, so that even if your individual product teams, they want to block Windows Update port to prevent Windows to be updated, still administrators can enforce through admin rules always allow. I will show you that later how it means. Okay. So I want to dive deep into more why we need secure admin rules from enforcement perspective. So as I mentioned, admin rules can help admins, enforce security easily. So why it's better than the current models, so I listed here, there are three kinds of the models used by a lot of customers today. And none of them can effectively have the security enforcement. So first model is that the NSGs are managed by a central governance team or network administrators. Okay, so essentially, our product teams, individual teams, they cannot touch NSGs at all. So you can enforce important security rules, but the downside is that the operational overhead is very high because you need to understand all of the demands of NSGs for different teams and managing them in a rapid way and efficient way is very difficult. You need to have a very big team to make it happen. Okay, and this is gonna be operational burden when the number of NSGs grow. And the second model is like you have NSGs managed by individual teams, and maybe central governance team can give some guideline, but there's no way to have enforcement. So obviously, the benefit is that individual teams, they can work in an efficient way, that they have flexibility to control whatever they want to have in NSGs. But the downside is that the governance team cannot enforce critical security rules, and oftentimes product teams, they don't have experts in security space, so they might have some security issues in their NSGs. And even more, there might be a security hole in the organization. For example, the social attack can, let's say, ask you, okay, open this link and you can get some free gift, etc. And once you click that link, you'll be logged on to Azure portal and modify the NSG and create a bigger hole, things like that. And preventing that for individual team would be very difficult without an enforcement. So a little bit better model in model 3 is that NSGs are still managed by individual teams, but central governance team can use Azure policy to have some standard rules to be inserted when you create NSGs for, let's say, new networks or new VMs. But obviously, the benefit is that you have some kind of the enforcement in that standard rules, important rules, by default created in NSGs. But it's very hard to enforce, as NSG owners still can modify those NSGs. And when they modify NSGs, even if you can use Azure policy to say, okay, once the resource is modified or non-compliant, please notify us. But getting the notification from different teams can be overwhelming, and some teams they can also create higher priority rules in NSG to bypass those standard rules. So in a nutshell, there is no effective way to enforce security in the environment. So the introduction of admin rules will solve these issues. It basically combines the benefits of these models. So the model is like you have administrators, right? They create admin rule to place some guardrail rules. Say, okay, some of the high-risk traffic, high-risk ports are prohibited, okay? And the rest of the rules could be stated in an NSG way. So still individual teams, they can have the flexibility to maintain whatever they want to have in NSG. So you get the benefit of flexibility and security enforcement. And what's more, you have limited security, exposure in that, unless, the network administrator or central governance teams who created admin rule is compromised. There's no security hole created, right? So this is the very big advancement in the security enforcement space. And another reason you want to use secure admin rule is that this is security at scale. What it means is that you can easily create day zero protection for your environment. So remember, network admin rule can be applied at the VNet level. So you can say, okay, I want to block some high risk port for my network group, let's say production network group. So every time you have, new VMs, created in your environment, it's gonna be automatically applied with the admin rule, so that your resources are protected from the moment when they are provisioned. Okay, and this can also work well in the brownfield scenario where you have already had resources. So the scenarios like you identify, okay, in your environment you have some security vulnerability or some issue. You can patch that easily with secure admin rule. You can say, okay, I identified some high risky ports are opened, wide open, for example. Then I can use secure admin rule to block such kind of traffic, let's say for the production network group. Once you apply that, all of the VNets, would be applied with this configuration, and this can be done in a few minutes. And traditionally, if you need to fix this hole in all of the NSGs, it's gonna be a very difficult thing. It's operationally very difficult. So we allow customers to have the ability to secure at scale. Okay, let's move forward. So I want to review how secure admin rules work with NSGs. So as I mentioned, they can work in parallel. So how it works in parallel is that essentially they're separate rules, and how it works is the order of network traffic evaluation. So as you can see from this diagram, when the traffic comes to secure admin rules, we have three kinds of the rules in secure admin rules. So in NSG, you have allow and deny, and in secure admin rules world, you have three kinds of the rules, three kinds of the permissions: allow, always allow, and deny. So we say like terminating versus non-terminating. Terminating means the evaluation would stop there. Okay. And non-terminating means the traffic or the evaluation is complete at the secure admin rule stage and pass on to NSG. So for example, if the traffic comes to secure admin rule and it is allowed by one of the secure admin rules, then it's gonna be passed to the NSG rules. Okay, but if you have some traffic, let's say hit by always allow rule, then automatically it's allowed without going to the NSG rules, and deny is the same as well. So this is the illustration of how this works. So with that in mind, I want to share with you two kinds of the design patterns here. So the first one is you have allow rules followed by deny all. So essentially, administrators can define specific traffic to allow, and everything else would be blocked. So this is the, pattern where you want to specify only some traffic should be allowed. What to be allowed explicitly, okay? And another design pattern is basically the opposite. You explicitly specify what kind of the traffic should be denied. So administrators can enforce some kind of traffic to be blocked, okay? And if this traffic is not blocked, the traffic would be evaluated by NSGs. So it's up to NSG owners to decide if they want to block or not. So this is useful in that what are the traffic should be blocked explicitly. For example, you say high risk ports ABC should be blocked. If you have the specific list of the traffic to be blocked, then this is a model that you might want to use. Okay, let's move forward. So a bit dive deep into how you can use secure admin rules. So in a nutshell, there are 4 kinds of the concepts here: admin rule, rule collection, and network group, and association. Okay, so for example, in this diagram, I want to create admin rule specifically for application 1, and I place that in the rule collection for application 1. You can do the same for application 2 as well. And what's more, you can create some common rules that should be applied to all network groups, right? You can see the rule collection in the middle. And then you can associate these rule collections to network groups. Okay, for example, admin rules for all that should be associated with all of the network groups. So in this way, you can also have the modularity in that, let's say if you modify or add one common rule for all of the network group, then in the past, when you want to update some common rule for all NSGs, it's gonna be very cumbersome. But with network managers construct, it's simply you just need to have one rule inserted into the rule collection for admin rules for all rule collection, and it's gonna be automatically created or updated to all of the components in the network groups. So it's very easy. So just to recap, you want to create network group, a logical grouping of network resources, virtual networks, and then you create a rule collection and you associate them. You create association between network groups and rule collection, and then your security configuration will be created, and then you commit this configuration to network manager, and network manager would automatically apply the configuration to the VNets in the network groups for you. Okay, this is how it works. And here I want to also describe how security can be enforced in a hierarchical way. Basically, different teams can work together using different network manager. to orchestrate their security management. So for example, you can have a root management, right? And this root management group can be managed by, let's say, a central governance team. Okay, and this central governance team can use the top level management group as the scope in the Azure Virtual Network, Azure Virtual Network Manager at the top level. Okay, and they can, let's say, specify, I want to deny all of the inbound SSH traffic, for example. And under that, I have management groups for different organizations. Like you can say different product groups. That's also a possibility. And let's say organizational one, the administrator of organization one, they create another network manager as using the scope of org1 management group, and they expressly specify that they want to deny all of the inbound UDP traffic, for example. So looking at this diagram, or what's going to be created is that you have, the virtual networks on the left-hand side, 3 virtual networks, right? And they will have 2 admin rules applied. One created by the, let's say, top level network manager, and another admin rule created by org1 network manager. On the other hand, the virtual networks on the right-hand side, you have only one security admin rule created. So in this way, you can create, security admin rules in a hierarchical way to work seamlessly between different teams. Okay. So now I want to have a quick demo to illustrate what it looks like to use Network Manager. So let me stop the sharing and share my, let me share my portal. Okay, can everyone see my screen?
Yeah.
Okay, great. So, okay, so this is the page of Network Manager. First, how you can use is, let's say, you can type Network Manager, and here you can find it. Okay, and I already created one Network Manager, and this is the Network Manager I created previously, because deployment of Network Manager can take a few minutes, so I already created a complete version. But let me walk you through the whole process. So first, just like other products, you specify where the Network Manager instance should reside. Okay, and let's say I want to create, AVNM webinar 02 resource group here. Then I will say webinar 02 AVNM. And this is where this instance would reside. But keep in mind, Network Manager can control all of the virtual networks, as long as it's in the scope. Scope means here. So here, let's say I want to manage the scope of, let's say, this one. Then no matter where the virtual network, is located, no matter it's in East US, or Asia or Europe, as long as it's covered in this scope, then this network manager, let's say in East US, can control. And what's more, you can see you have a lot of options. So network manager can manage your resources, globally across different subscriptions. And here you specify the features that you want to allow. Okay, basically that's it. And let's create. Okay, now what I want to do is I have 50 production virtual networks and 50 test virtual networks. And I want to connect them to a hub. So I'm going to create a hub and spoke topology, right? And then I also want to have security admin rules applied to the production oriented virtual networks so that I can enforce some like strict network policy to make sure that those virtual networks are secure. So let's see how I can do that. So first, as I mentioned, I want to create a logical grouping of network resources here. I want to create a prod network group. And this is the basic editor. As I mentioned, you have the GUI to help you select from, different parameters. So let's say I already created virtual networks with the name prod. Okay. And you can preview the resource. Okay, you already evaluated for you. These are the virtual networks meeting this criteria. And let's say I also make sure that it is in the resource group with the name, and then webinar 02. Let's double check again. Okay, it's as expected. Then I create a review. Okay, this is the JSON syntax that will be created. So indeed, you can also use, advanced editor to create this one. Likewise, I want to create a test network group. The name should contain test, and the resource group should have this condition. Let's see. Okay, as expected. Let's review and create. And now with this configuration, I want to create a hub and spoke. So I will say my hub and spoke. Here I say I want to have a hub and spoke. Let's select a hub. So I want to say from my hub, hub. Okay, this one. Let's use this one. And I connect these network groups, to this hub. Let's say create. So by default, it's enabled to use the hub as a gateway, but now for the sake of the demo, I don't select them. And by enabling this option, I make sure that all of the VNets in this network group can talk to each other. So essentially, I'm creating a hub and spoke topology with direct connectivity between the spoke network groups. Okay, so let's create this one and security admin rule configuration as well. So let's say my security admin config, and I create a rule collection. I would say strict rule collection. I'm targeted here, and I'm going to add an admin rule. So I want to say, I want to block port 80. I want to name it like this. Priority is 1, just like NSG's priority. The action is to deny. And direction outbound. Okay. Source star, port star, star, and port. Okay. So no outbound traffic from port 80. Okay, I'm going to add this one and save. And I'm going to add this and save. Okay, now I have the secure admin rule. Now, what you want to do is to deploy the configuration. So let's start from deploying the connective configuration, my hub and spoke. You can select whatever region you want to deploy this configuration. So I'll put all of the resources in East US, so I can select this one. But if you have some resources in different regions, then you can select them. So this is the functionality that I mentioned previously. So let's say if you have all of the resource testing resources in, let's say, some of the smaller regions, then you can specify that region and test, and after verifying it's working as expected, then you can come to here and select the second region, things like that, to roll forward. Okay, so now let's deploy in East US. Okay, likewise, I'm going to deploy in East US my security admin configuration. And this process can take a few minutes. Okay, so you can see it's in progress. It's also in progress. So for the sake of time, let me show you the environment I already have. So in the resource group, webinar 01, I already created, an environment that applied, those configurations. So let's say if you go to the VM that I put in the production network group 01, you can see how it is making effect here. So here you come to outbound port rules, and on top of NSG rules, as I mentioned, I wanted to have the port 80 to be blocked. So here you have NSG section, and here is admin rule section, and you can see admin rule is blocking the port 80 here, right? And I also created the hub and spoke topology. So from the perspective of this this NIC in the production VM in production VNet 1, you can see their effective routes. So here, as you can see, you have peering connected to your hub. This is the address of the hub, and these are the IP prefixes of the spokes. So I use connected group to connect to the rest of the spoke VNets and have the peering to connect with the central hub. So in this way, I easily use connected configuration and security configuration to create a hub and spoke topology with security enforcement at scale in a few clicks. Okay, so this is my demo. So let me wrap up my presentation. So here I have a few links here. So you can click on this one to go to the product page, and we also have public documentation where we describe how you can use all of the functionalities that I described today. And even we have a introductory blog announced, so you can read the introduction blog to just see how it works. And all of the materials are already available today. And feel free to reach out to us with this email address, and then preview feedback at microsoft.com. So thank you for attending this webinar. I really appreciate your attendance. And do we have the Q&A time for today?
Yeah, the team's been great with answering the questions, but we do have a couple that were unanswered. The first one is there any predefined template for defining complete infrastructure subnets VLANs ahead of time?
Let me see, where is the question? I mean, VLANs?
Yeah, so is there any predefined template for defining complete infrastructure subnets or VLANs ahead of time?
Yeah, I don't think we have this covered at this moment. Yeah.
Okay. The next one is, does connected group create VNet peer connections between VNets and a group?
No. So peering and connected group is separate concept, but both of them can create direct connectivity, which means either you use peering or connected group is both, the direct connectivity without, without extra hub. So the latency is minimum. Yeah.
Great. And then we have another one. Can NSGs be used on Azure Arc devices that are on-prem or other clouds?
You mean Arc devices? Let me see. Okay, yeah. So at this moment, I think Arc devices. I think can Ashish or Muhammad can answer this one. I'm not that sure about Azure Arc, unfortunately.
No, at this point of time, no.
Great. We have a few more. Are you planning to add network address space at the enterprise level?
Yeah, we're looking into this, capability.
Great. And the next one is, do you have a cost regarding connecting group?
Connecting group. What does it mean? Is that connected group or the
Connected group.
Because I see it says connecting group. So okay. So connecting group or connected Connecting group, I think the question is about connected group. So connected group has no cost, so it creates connectivity for you, and the cost of traffic between VNets within the connected group is charged as the same as how you charge for peering. Yes.
Great, thank you. So I'd like to thank Jay for being our guest today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you and see you next time.